Welcome to the deep dive. Today, we're digging into a really fascinating piece of the dinosaur puzzle from way back in the late Triassic.
Yeah, this one's from southern Brazil, Buriolestes schultzi.
Exactly. And we've got some great scientific papers here covering its discovery, its anatomy, the whole story. And our mission today really is to figure out why this relatively small dinosaur is actually a massive deal.
Right, because it connects to the Sauropodomorphs, the line that eventually gave us the huge, long-necked herbivores.
But here's the twist. Buriolestes seems to have been, well, a meat eater.
That's the kicker. It really shakes things up. We're talking about finds from 2009 initially in the Burial Ravine.
And more finds came later.
Yeah, and altogether, they've made Buriolestes one of the most complete Triassic dinosaurs we know. Seriously.
Wow. So, like, comparable to the big names, Eoraptor, Herrerasaurus.
Absolutely. Up there with Eoraptor, Colophysis.
Yeah.
Getting that much information from so far back is, well, it's gold dust for paleontologists.
Okay, so let's talk about the name. Buriolestes schultzi. Sounds like there's a story there.
There is. The Buriolestes part, that's a nod to the Burial family. It was their land where the first specimen turned up.
Ah, nice. And the lestis.
That's Greek. It means robber or thief.
Okay, hinting at that carnivorous side we mentioned.
Exactly. And schultzi, that honors the paleontologist, Cesar Schultz for his work.
Gotcha. And these fossils all come from one particular place.
Pretty much. The Santa Maria Formation in southern Brazil. And geologically speaking, we're talking the Carnian Age, late Triassic, a really key time for early dinosaur evolution.
And I heard Buriolestes wasn't found alone. There was something else nearby.
That's right, yeah. Found right alongside the main Buriolestes specimen was Ixolerpiton.
Which isn't a dinosaur.
Nope, not quite.
Yeah.
It's a dinosauromorph, closely related, part of the loggerpitid group. But finding them together is super interesting.
Why's that?
Well, it gives you a snapshot of the ecosystem. It shows that early dinosaurs like Buriolestes were sharing the landscape with these other similar reptiles.
Yeah.
They weren't instantly dominant.
Okay, so let's get to the really surprising part. You look at Buriolestes, maybe just its skull. What's your first impression?
Predator. Definitely. See those teeth? They're finely serrated, a little bit curved.
Built for slicing.
Totally. Looks perfect for grabbing small vertebrates, maybe some soft-bodied invertebrates too. Classic carnivore setup.
And yet, it's classified as an early member of Sauropodomorpha, the group leading to Brontosaurus.
Exactly. That's the mind-blowing part. It's one of those hold-on-a-second moments in science.
So this suggests the ancestors of those giant plant eaters were actually eating meat.
It strongly points that way. The thinking now is that the common ancestor of sauropodomorphs, and probably all saurischians, the group, including theropods and sauropodomorphs, was likely carnivorous.
Wow. So herbivory in the big sauropods was a later adaptation.
Seems like it. This little robber Buriolestes gives us a glimpse into that earlier meat-eating phase for this iconic lineage.
But surely there must have been some clues in its skeleton, besides the teeth, that linked it to the later sauropodomorphs.
Oh, for sure. Even though it's early, it does have some key sauropodomorph traits. Subtle things.
Like what?
Well, its jaw tip is slightly downturned at the front, and on its upper arm bone, the humerus, there's a feature called the delta pectoral crest, basically a ridge where muscles attach. In Buriolestes, that crest is long, in a way that's characteristic of sauropodomorphs. It's like an early blueprint.
So the connections were there, even with the meat-eating teeth.
Exactly. The underlying body plan was already starting to show those features.
But it probably didn't look like a tiny Brontosaurus with fangs, right? It must have lacked some later feature.
Oh, absolutely not. It didn't have that tiny head relative to its body size that you see in later sauropods. And its nostrils weren't huge or shifted way up high on the skull like in the later giants. Those are probably adaptations linked to bulk feeding on plants later on.
And didn't you mention it has a unique feature, something only Buriolestes has?
Yeah, an autapomorphy. It's a specific little detail on the tibia, one of the lower leg bones.
Okay.
There's a bump, the medial condyle, that projects backwards in a very specific way. It's like its own little anatomical signature.
Huh. And what about other differences? How do we tell it apart from, say, early theropods or the ornithischians, the other major dinosaur groups?
There are quite a few skeletal details. For instance, look at its pelvis. The pubis bone, its shaft is pretty straight.
Okay. And how does that compare?
Well, later sauropodomorphs get this broad, sort of apron-like expansion there. Theropods develop a distinct boot shape at the end, and ornithischians rotate the whole thing backwards, so Buriolestes is different. Also, the front part of its ilium, another hip bone, is relatively tall compared to some others.
Gotcha. Subtle stuff.
Yeah, and there are other things too, like beveled edges on the pubis, specific kind of shelf on the femur, the thigh bone, and a relatively long bone in its fifth toe. Lots of small clues add up.
Interesting. And when you look at the different fossils found, do they all seem to be the same size?
Not exactly. There seems to be some variation even in adults. Most estimates seem to put them around, say, 6 to 7 kilograms, maybe like a fox or a big cat.
Okay.
But there was one specimen found at a site called Pichet, the first one found outside the original spot, that was clearly more robust.
How much bigger?
Potentially over 15 kilograms.
Mm-hmm.
So more than double the size of the others. Suggests some real size variation within the species.
Now, switching gears a bit, there was some news in 2022 about its bones, something about air sacs or the lack of them.
Yes, that was a big deal. They used micro-CT scans to look inside the bones of Buriolestes and a couple of other early Saurischians.
And what did they find?
They found that the bones weren't pneumatized, meaning they didn't have that extensive system of air sacs invading the bone that you see in later dinosaurs.
Like in big sauropods or birds.
Exactly. And in pterosaurs, too. Those groups have very airy skeletons. But Buriolestes and these other early ones, nope. Solid bone.
So what does that imply?
Well, it strongly suggests that this whole air-filled bone thing, vertebral pneumaticity, didn't just evolve once in a common ancestor.
It popped up multiple times.
Looks like it, probably at least 3 separate times.
Mm-hmm.
Once in pterosaurs, once in theropods leading to birds, and then again within the Sauropodomorph line.
Wow. Okay, so it's convergent evolution.
Precisely. Which really changes how we think about the evolution of these big archosaur groups. It wasn't just one simple invention.
So putting this all together, where does Buriolestes actually sit on the dinosaur family tree based on all this evidence?
The analyses consistently place it right near the base of the Sauropodomorpha. Think of it as one of the earliest twigs on that branch of the tree.
Okay, a foundational member.
Exactly. Now, its precise relationship to other very early dinos, like Eoraptor or Pampodromaeus, that's still debated a bit.
So?
Different studies find slightly different arrangements. Some group them together. One analysis put Buriolestes as the closest relative, the sister taxon, to Eoraptor. Others put it as the most basal, the very earliest sauropodomorph known.
But the general picture is clear. It's right down there at the beginning of the Sauropodomorph story.
Definitely. And that position, combined with those meat-eating teeth,
really reinforces that idea we talked about earlier. The ancestors were carnivores.
It's compelling evidence. It suggests the default diet for the earliest dinosaurs, or at least the earliest Saurischians, was meat. And that shift to eating plants happened later, and maybe independently in different groups.
Like the Sauropodomorphs went one way, the Ornithischians another.
Something like that. Buriolestes is like a snapshot from before that big dietary divergence within this lineage.
And finally, let's circle back to it being found with Ixolerpeton. What does that tell us about the bigger picture of the Triassic world?
Right, the co-occurrence. We see similar things in other late Triassic sites, like in Argentina. You find early dinosaurs living side by side with non-dinosaur dinosauromorphs.
So it wasn't like the dinosaurs just showed up and immediately wiped everything else out.
Doesn't seem like it.
Huh.
It suggests a more gradual transition. Dinosaurs and their close relatives coexisted for quite a while after dinosaurs first appeared. It wasn't an overnight revolution.
So Buriolestes is, well, it's more than just another fossil name. It's kind of a key witness to the dawn of the dinosaurs.
Absolutely. It captures that early evolutionary experimentation.
Especially that unexpected carnivorous start for a group famed for its plant-eating giants.
Yeah, it shows how lineages can change dramatically over time and how early forms can hold on to ancestral traits while still hinting at future directions.
This whole dive into Buriolestes really underscores how much is still being discovered, how dynamic our understanding is. And it makes you think, doesn't it? If something as basic as diet, or even having air pockets in your bones, could evolve in these complex, multiple ways, what else might be more complicated than we assume? What other early dinosaurs might be out there waiting to be found that could completely rewrite parts of the story we think we know?
It's what makes this field so exciting. You never know what the next discovery will reveal.
Buriolestes is a perfect case study for that. Really fascinating stuff. Thanks for walking us through it.